really just parametric curves. Now, so you're going to see this now, and we're going to interpret it a couple times, and we're going to think about polar coordinates. These are all preparation for thinking in more variables and thinking in a different way than you've been thinking before. So I want you to prepare your brain to make a transition here. This is the beginning of the transition to multivariable thinking. We're going to consider curves like this, which are described with x being a function of t and y being a function of t. And this letter t is called the parameter. In this case, you should think of it, the easiest way to think of it is time. And what you have is what's called a trajectory. So this is also called a trajectory. And its location, let's say, at time 0 is this location here, x of 0 comma y of 0. That's a point in the plane. And then over here, for instance, maybe it's x of 1, y of 1. And I drew arrows along here to indicate that we're going from this place over to that place. These are later times. T equals 1 is a later time than t equals 0. All right, so that's just a very casual, it's just the way we use these notations. Now, let me give you the first example, which is x is equal to a cosine t, y is equal to a sine t. And the first thing to figure out is what kind of curve this is. And to do that, we want to figure out what equation it satisfies in rectangular coordinates. So to figure out what curve this is, we recognize that if we square and add, so we add x squared to y squared, we're going to get something very nice and clean. We're going to get a squared cosine squared t plus a squared, sorry, that's not a cubed, that's a squared, sine squared t. Whoops, yeah, that's right, okay. Which is just a squared times cosine squared plus sine squared, or in other words, a squared. So lo and behold, what we have is a circle.